Okay, 9-1 day 2. We got a few more things to look at in terms of kind of general concepts about significance tests before we actually dive into doing them. Today is really looking at error types. Okay, the first thing to be clear about is that there's 2 of them. Okay, and the little grid down here kind of shows you really 4 possibilities when we do our test. Okay, because we kind of left off in day 1 saying we calculate, the big part of the test is we calculate this thing called a p-value, and if it's little, we reject HO. If it's big, we fail to reject HO. Okay, that's kind of how it works. Because of the variability involved and the fact that we're operating off of a sample, there's always a possibility that the conclusion that we come to is not correct. That's, if you're working with samples, that's inevitable. Okay. So if we were, I'm looking down at the grid now, I'm on the top left. If we were to reject HO, which is basically implying that we think it's false, when it's actually true, we call that a type 1 error. It's right here. That's a type 1. Okay. If we fail to reject HO when it's true, that would be right here. That's okay. That's the conclusion we would like to come to, right? If HO really is true, I hope we don't reject it. Okay? Over here, if we fail to reject HO when it's actually false, we call that a type 2. Okay? And it's the only possible errors that we could make. If we reject HO when it's false, that's wonderful. That's what we were hoping to do. Okay? So the big thing on this slide is that you understand there's 2 types of errors and that you know what they are. Type 1 and type 2, right? I usually start with a type 1 rejecting HO when it's true. Okay? And if you keep that one straight, 2 is just the opposite, right? Switch both parts. We didn't reject HO, we'll fail to reject it, not when HO was true, but when HO was false. Okay? This grid can be pretty helpful. All right, here we're going to look at a little context. This slide is also important in terms of what you would be asked to do. Okay? So the context is at a restaurant. They're examining the proportion of customers that can get through their drive-thru in under 2 minutes. Okay? Let me rephrase. Better way to look at this. The proportion of customers that are having to wait over 2 minutes, because that's the statistic that we have, or at least the parameter at this point. The statistic that we would look at in a sample. The restaurant believes it's at about 63%, so we're saying P is 0.63. Okay? They believe that that's too high, and they want that number to come down. Okay? So they're thinking about putting an extra worker. Okay? It describes right there what a type 1 error would be, and this is something that you should get to the point where you feel comfortable doing. All right, so they add the worker in the hopes that it reduces the proportion of people that are waiting over 2 minutes. Okay, a type 1 error. Okay, now remember to think that through. Okay, I'm even going to write it out right next to it. In this case, right, don't write this because, right, it says to explain it in the setting. The definition can help, but you got to have the context. But I think this is a really good reminder to put with it. That's what a type 1 error is. Okay? So here, if we reject HO, we believe the worker made a difference. and there's fewer people waiting over 2 minutes, and we're wrong. Okay, we added the extra worker. We think it helped, and it didn't actually help. Okay, and this could happen. Like we could get a, if they took, I think somewhere in the next couple slides, yeah, here it's down here, that they were going to take a random sample of 250 orders to look at how long they waited. Okay, we would probably continue to do this, like adding the extra worker when they're not actually helping. Okay, a type 2 error. Failed to reject HO. Failing to reject HO when it's false. Okay? So if HO really is false, that means the worker made a difference. But we think that they didn't. Okay? Now read through the explanation there. I got to say something about, we added this extra worker. They made a difference. It really did reduce the proportion of people waiting 2 minutes or more. But we believe it didn't help. The extra worker is really helping, and we don't realize it. In this case, that's what a type 2 would be. Okay? It's common for us to compare them because depending on the context of the problem, a type 1 or a type 2 error can be worse. Okay? One can be worse than the other. Here, I don't know. This one, sometimes they're really, they always can be a little bit subjective as to which one you kind of interpret as being worse. But it's important to take a look at them, because if we get the feeling that one is worse, it can dictate how we set up our 4-step. All right, the last thing, really last two things, okay? Kind of goes with each one. First off with a type 1. This first line right here is big. The probability of, I'm going to just kind of pull that out over here. The probability of a type 1 error, this is a really big idea, is alpha. Okay? So this goes back to what I was just saying. We have talked about like 3 different values for alpha that we would use. 0.01, 0.05, and 0.1. If we get the feeling that a type 1 error is really bad and we don't want to make one, then we should make alpha really small. Okay? We should make alpha small. If a type 2 error is really bad, then we should use a little bit bigger alpha value. Okay? The last thing in terms of definitions is to talk about power. Okay, I really like my definition. You should equate power and type 2. Those two go together. Okay? In fact, you're going to find that they're complements. Okay? I really, really like the last part of the definition. It's like the probability that we correctly reject HO. Okay, because remember, if we're talking about a case where we could be making a type 2 error, okay, a type 2 is failing to reject HO when HO is false. Okay, so this whole time, if we're talking type 2 or we're talking power, the null hypothesis in reality is false. Okay, we want to reject. There's just no guarantee that we will. Okay, so type 2 in that circumstance is the error. If we avoid making that error, we call that power. Now, the two are complements. probability of a type 2 error plus power is 1. Okay, because if it is a case where you should reject HO, you have two possibilities. There's the probability that you do, and there's the probability that you don't. All right, think of power as the probability that you do reject HO. Type 2 is the probability that you didn't, and that ends up being the error. Okay, we're going to look at this on some normal curves here in a minute. The big thing with power is if you want to talk about it, you have to specify a specific value for HA. You have to specify a specific value. In the next slide, I will get into that more because I want to give you like 3 little diagrams where I'm going to talk about power. But to do that, I have to say, here's a specific parameter value. And if I mess around with that value, all these probabilities would change. Okay? All right, now I'm going to draw a bunch of normal curves. Okay? Now, I'm going to leave out some of the details here. But I just want to give you an illustration as to what's going on with all this stuff. Okay? This first set of diagrams is going to be at alpha 0.1. We would call that a higher alpha value. All right, so this sampling distribution, we could calculate its standard error. I'm not going to write it in there because I don't want the diagram to get too cluttered. In reality, I probably should. In fact, I will. I'll calculate it real quick. It's the formula for a standard error of a proportion. It's like okay, that would be alpha. Okay, so all these probabilities that I'm going to throw on here, I'm not going to like calculate them, but you could. It's just using a normal CDF or an inverse normal. All right, but if alpha is 0.1, that means to reject, I need a sample that's down in the bottom 10%. Okay, this part would come from an inverse norm. What that means in terms of my sample of 250, I need to see that 59, like the proportion of customers waiting at least 2 minutes, went down at least 4%. I need to see it go down to at least 59. That's the cutoff as to where I'll reject. Okay? That's the cutoff as to where I'll reject. Now over here, for every single one of these, because I also want to get into type 2. But remember, I said if I'm going to talk about type 2, I have to specify an alternate value for P. So I'm going to say that this extra worker at the window made a difference, and it reduced P from 0.63 to 0.6. Okay? Here's how this would how it would look. Okay? From my sample, my area where I would cut off reject or fail to reject is going to be at 0.59. Any one of these samples would lead me to reject. Okay? That's a normal CDF that I would use to get that. I would still just use the same standard error. And over here, it would be 0.62, okay, for the unshaded. This 0.38 over here, for this particular test, that would be its power. Right? If P really is 0.6, at alpha 0.1, I'd have a 38% chance that I should reject HO as I should. Over here, this 0.62, that's called a type 2 error. Okay? For this particular setup to the test, right, again, if P is 0.6, that's going to be a tough, I'm pretty likely to make a type 2 error. Okay? Now, let's do the same setup, but let's change alpha and say alpha is 0.05. My sampling distribution is still going to be normal. Centered at 0.63, my cutoff here moved to the left. I'm making it harder to reject HO. Okay, that cutoff right there, again, this would just be an inverse normal if you wanted to figure this out. It's not going to be at 0.59. I'm going to say to reject, I need to go down to 0.58. Okay, I need to see a 5% drop from our sample of 250 if I'm going to reject. That is going to change things over here. Centered at 0.6, right? This moves to the left because now my cutoff between reject and fail to reject is now at 0.58. It's right there. This is still power at 0.24. Type 2, 0.76. Okay? So alpha went down, probability of a type 2 went up. Remember, alpha is the probability that I make a type 1. Okay? I'm going to do one more here. We're going to switch alpha one more time. Now let's say alpha is 0.01. Still centered at 0.6. My cutoff is way down at the bottom. I'm saying if I'm going to reject HO, I need one of those samples. Way down at the bottom. Okay? The cutoff for those is 0.55. Notice as alpha is going down, I'm making it harder to reject HO. I'm saying I don't need just a little bit of a decrease in this proportion. I need a big one. I need an 8% drop before I'm going to reject HO. Now that means that my odds of making a type 1 error are really small. Type 2 is going to be really big. Because now the cutoff is right here. And remember, this shaded area over here, that's power. And for this test, the power would only be 5%. But the odds that we make a type 2 in this case are 95%. Okay? Now, last thing I want to do is just kind of summarize what you're seeing in all this stuff. I started by playing around with alpha. If I made it go up, then the probability of a type 2 would go down and power would go up. So you can think of alpha and power, those move together. Okay? And this could just be flipped as well. If you decrease alpha, that's the probability you make a type 1 error. That's going to go down, but the probability that you make a type 2 will go up. And your power will go down.